So now that we have engaged the students with the concept of thermal energy transfer through the experience of radiation, we're going to actually introduce to the students a scenario, a real world scenario with a problem where they'll have to apply the engineering design process to create a solution. So the students will be organized into pairs, and it'll be explained to them that we're going to use the engineering design process to create a solution to a problem caused by thermal energy transferred from the hot summer sun. And we're going to hand out the Cool Puppy worksheet for the students to use and to go over so that they understand the concept, the scenario, the constraints of the problem, and the process by which they can use to actually solve it. So in this scenario, students will imagine that they have found a lost puppy that has no identification. They bring this puppy home and their parent tells them that they can keep the puppy for now, but the puppy's not allowed to stay in the house. So it's summertime and the student has to create and build a structure for the dog to rest and sleep in that will not become too hot in the summer heat. So the constraints to this project are that the students have $12 of their allowance money that they can spend. This is a budget for creating the structure. So the students will actually be given Monopoly money, $12 of it, and they'll be able to shop at and buy supplies from a class hardware store to actually get the materials they need to build this doghouse. And for this project, the students have to do the following. They have to keep a budget tracking report of the supplies that they, quote unquote, purchase. They have to design and build a structure using the design engineering process. And the structure has to fit the puppy in it, which will have little stuffed puppies for them. It has to keep an internal temperature under 32 degrees Celsius or 90 degrees Fahrenheit when it is out in the sun for 30 minutes. And we'll replicate this experience with a heat lamp. Also, the structure needs to have an exit for the dog to leave the doghouse when it chooses to in order to reach a water dish. And the structure needs to be self-supporting. So with the students, we're going to review the engineering design process and the scientific concepts of thermal energy transfer. I'm going to hand out to the students in their pairs. Each of them will get a stuffed puppy animal that they'll be able to measure the dimensions of when they're planning their structure. I'm going to give each of them an engineering design process worksheet, and each of them will receive $12 of Monopoly money that they can use for purchasing supplies. So we're going to go over, before the students actually start building and purchasing materials, we're going to review the engineering design process. I'm going to explain to the students that when they're faced with a problem, a real world problem, the engineering design process guides you in your development of a successful solution, and explain that professional engineers use a form of this process to create solutions to real world problems. And the version of the design process that we'll be using involves the following steps. First, asking, what is the problem? Then imagining, brainstorming possible solutions to that problem. After that, planning, settling on one of the solutions, and sketching or writing out a description, perhaps doing some research of necessary scientific background to inform their planning and design, and to work within the limitations that the situation might impose, whether it's budgets, materials, tools, time. Following that, the students then begin to create. They gather their materials and tools, and they start to actually build their solution. Then, finally, improve, where they actually test their solution, whatever they've created, and based on the results of that testing, they think about ways that they could actually make it even better. So before the students actually do that, we would review a few more scientific concepts related to thermal energy and the materials that they'll be using with the project. So we've already talked about thermal energy, which is experienced as heat when thermal energy is transferred from one object to another. One object is making another one hotter. In this situation, the sun is making the earth and the air and can make materials like the leather in a car that we talked about, like a chocolate bar sitting in a car, like metal on the surface of a car, a lot hotter. So this is also true for the doghouse that they'll be building, and they have to make sure that it doesn't absorb too much heat. We'll talk about how the thermal energy transfer is something that we want to be minimizing in the case of the house that they're building for the puppies. So the other two concepts we'd really like to talk about, because this is going to have a lot to do with the materials they'll choose to use, are thermal conductors and thermal insulators. Thermal conductors are materials that transfer thermal energy quickly and easily. A good thermal conductor is metal, a solid that changes temperature quickly and easily when heat is applied to it. Thermal insulators are materials that transfer thermal energy poorly, meaning they do not absorb heat easily or quickly. And examples of good thermal insulators include fiberglass, which is used as insulation in houses to maintain a stable temperature, and styrofoam, which is often used for cups to keep a drink cool or to keep it hot because it does not itself absorb the heat away from a drink or add heat to a drink. So our vocabulary for this lesson, things that we've reviewed with the student up till this point, include thermal energy, radiation, thermal conductors, thermal insulators, and the engineering design process.